So if you go to github.com/datatas, you can have a look at, so I'm just going to go github.com/datatas here. Our repository is in here, and it should be the one called Accessing Mapping GBIF Data. You have our studio and everything that was plain email installed in your computer. You can simply clone this to your machine, to your local machine. So you either have the option of using HTTPS or SSH keys, depending on what how you have set up your computer. Usually it's the HTTPS that the most people have, and then you can copy these whenever you're using you're cloning this repository into your computer. If you don't have any knowledge of how GitHub works, that's fine. You can simply download zip, and it will download a folder that is being compressed. So you can uncompress it, and you will have all the information that you need available to you. If for some reason you don't want or you are not able to install anything in your computer, finally learn how to set up Binder. So if you click here, launch Binder, you will open up it will open up a Jupyter Notebook thingy in your web browser. It does take a little while to show up. So this is what you will see when it first loads. So if you want to actually use RStudio, you have the option of clicking here, and it will open the RStudio server. You don't need to do anything other than clicking that RStudio. So this is the server here now. It will probably ask you to download a few libraries, and it will give you a small message at the top here saying what libraries you need to install. You can just simply click install and you're good to go. Probably before you open anything, it's good that you have the R project actually open, because it just knows where I'm using relative path, so you can't, I don't put that in there, it won't work properly, all the scripts that I share with you. So it's important that you first go into the R project, open it up just by clicking on it, or if you go to here and then open project and select the project that you want to open, which it's a file editing R brush, as you see here, and you're good to go. Okay, so that's all I need to say. If you want to run these in your computer, for the email, you have to have R installed, at least version 4.0 or the latest one, it still works. You should have RStudio version 1.2 or above, and you should have R tools installed in your Windows machine. Linux and Mac OS do not need R tools. Okay, and yes, otherwise, as I mentioned before, if you prefer not to install anything, you can just use the Binder option and it will bring you to here. Okay, so if everybody is all good to go, we can start.
Can you increase your font size?
My buffer?
The font size or the...
Yes, I'm just swapping my screen now. So what I'm going to use. Okay. There we go. This is what we have. I'm just going to close this one. The first one that we're going to do is actually accessing the GBIF data. So they are .rmd files are markdown files, which are basically documents that allow you to include text as well as code all in one. And when you run the code, it updates the document with whatever outputs you have. So all the areas that you see in gray, like this one here, are the ones related to the code that we're actually going to use. So in here, this basically is just how to set up this document. It's just saying that we're going to show all chunks, it's called, these are gray areas. or chunks of code will show up in the document. Here I'm including information about what GBIF is. You should also have a GBIF account because you need to be able to have access to the data. You need an account with them. It's free of charge. It gets followed the steps that they give you in the website if you go to gbif.org. So you will need these to be able to download the data set. So here are the instructions. You need to make sure that you have your username, your email, and password that should be linked to your GBIF account. So just to show you what the GBIF account is like. So if we go here to GBIF.org. So here is already logging as myself. A little bigger. So you see that's my my handle or my username, and everything that I download will be linked to that account. So you have to have one key. There we go. So it also gives you information about the packages that we're going to use. If you plug these into your directory, you should be able to use this file in here called the rnv.log. So basically, that file contains all the information about the environment, so all the packages, the version of each package, and all the dependencies that those packages need. So you can activate that by using rnv. So rnv should be installed. That's the name of the package. If you haven't installed that, just go install the background step. So if you haven't installed rnv, just go install your packages, and then in quotation marks you go rnv. If you're not sure if you have rnv installed, you can go to the packages tab here on the, usually it's on the lower right hand side. You click on there, it will give you all the packages that you have installed in your computer. So if you check for rnv, it should show up. If it's not there, then it means that you need to activate it. So if you go install packages, I'm just going to do it now. So it will start thinking about like where to download it. So you will see the stop time in there, and it will just if it's all fine, it will go back to that little more than sign as you see here. So that's already done. So I don't need to call library rnv because I'm using rnv, and then I'm using these two columns together to let R know that I need a function from that package. So I don't want to load the whole thing. I just need this one function in particular. So if you go rnv activate and then press enter, it will load the environment that I had in my computer when I created these notebooks. I'm not going to do it at the moment because it's already has what I need. And then it will probably, if you don't have any packages, it will ask you if you want to download any packages that are missing in your computer. Just go yes, and it will download. Probably it won't. Don't do it now because it will probably take a little while, depending on how many packages you need. So you can do that later. Okay, so now we're going to start talking to GBIF. So what we need to do first is, as I mentioned before, our login details. So again, that will be your password, that will be your email address, and your what do you call it, the username. So we're going to use this package called use this. So you will have to have this installed in your computer. And then again, we're using that format of like the two columns because we're going to use just one function of this particular package, so I don't need to load the whole thing. So from use this, I'm going to use this function that is called edit_r_environment. So that will edit the environment of R in general. So instead of having to use my username and my password, I'm just going to store it in my computer so it doesn't ask me again every time that I want to log in data. So I'm not going to do this because it will show you my password and information that no one else could have. But if you click on that, it will open up a new little tab in here that will set our environment. So you need to record this information in that new tab that shows up. You need to have the GBIF user. Then instead of putting your username in the quotation marks, you need to make sure that you have your actual username. So if I show you that I had before, my username is WinDef87, so that's what I will put in here instead of your username. Password, the password that you use to set up your account, and the email will be the email that you use to set up your account in GBIF. If you have more than one, just make sure that you go into your account in GBIF to ensure that you have the right email address, otherwise you won't. So once you do that, just in that new tab that will show up with your environment, just go Control S for save, or simply press that little button here. I don't know if you can see it, but it's a little bit here, where if you press it, it gets saved. So once you do that, a message will pop up saying that you will need to restart R for this to take effect. So we do that by going Sessions at the very top. I can't make this any bigger, but if you go to the menu at the very top, there should be one that says Session, and then you should have the option of Restart R. If you don't want to use your menu, you can go Control, Shift, and F10. It does the same thing. So I'm just going to restart it. You see that it says Restarting R. So you see that it's starting the R session. And you should be good to go. So once you restart this, you don't want to run everything again. You can just go, if you want to nick this or produce the HTML file that the Markdown does, you just go to the first chunk and press that little play button. Otherwise, you can go Control Enter, and it will also run that particular line. And then we can keep going. So we already did this, edit the R environment, so we don't need to do it again. Again, this information should be the ones that shows that is stored in the R environment tab that you have. And then we are now ready to start querying the data sets that GBIF has available and trying to clean them up and see wherever we don't need that data. So in here, before we continue, we're going to load the libraries that are going to be useful to us for this particular notebook. So I'm just going to use RGBIF, which is a package that was designed to allow us to communicate with GBIF quite easily, and the tidyler, which is great to create really nice plots through GBIF plots, and just clean the data with things like dplyr. So again, you can go Control Enter to run each line, or if you prefer, you can go and press the play button there. If you see, it has now turned red, so that's when it's kind of like processing what we're trying to do. So if you want to stop it, you can press that red button. So now I have done it. In here, it's already simply letting us know what it has done. So there are no errors, it's just saying that what packages is loaded. Mostly because the tidyler is not one package, but like a compilation of multiple packages, and it tells you which ones they are and the version. And it also tells you that there are a few conflicts because dplyr has a filter function, and stats has also a filter function. So if we want to use these particular functions, it's probably better if we call it by its name and last name. So make sure that you include the package, followed by those two columns, and then the function. So this happens with filter and with lag only. Okay, so now as an example here, I just wanted to check information about Syrian Louis, which is the scout camera, just around Australia. So you can choose whatever species you want. It doesn't have to be this particular one. GBIF has information from all over the planet for a variety of species, from bacteria all the way up to whales. So you can choose whatever option you want. It doesn't have to be Australia, it doesn't have to be species. This is only an example of that. Okay, so the first thing that we need to do is actually search for the code that is associated with the species that I'm interested in. So again, I'm just using Syrian Louis as an example. So how do I get that information? We use this function called name_backbone, which gives me just the information that is recorded for that species in GBIF. So I'll just run that one. If I want to see what's stored in that particular variable, I can just go Lewini and the key, because that's where I save all the information. So if I just go like this, it will print what's in there. So you can see that it has only one row because it's only one species that I'm studying, but it has 23 columns, and it includes you here all the column names. But that's not particularly useful. You can't really see anything. It's not telling you much. So the other way that they can see the results a little bit better is using this links function that is part of GBIF. So it will give you a summary of what's included in that variable _key, which is containing all the information that GBIF has about my species. So in here, you can see a lot better. Yes, it tells you the same thing, one row, 23 columns, but now you can see that, oh, the usage key is this one. And all the other information that GBIF has stored for this particular species. So by the way, if anyone has any questions, either online or here, just raise your hand or write it in the chat. And let me stop in time. Okay, so now that we have that information, then we can start doing the queries. So we're going to use this OCC_download function that is again part of the GBIF package. So we're going to ask the database to store it out to GBIF to look for certain items here. So we're going to use this thread function that will let us choose the column name and the actual value that we want in that column. So in this case, I want to provide a taxon key, which is basically an ID for this particular species that I'm interested in. So if we go above a little bit, we can see that SLW key usage key is this one here. So that's the code that is associated to my species. So I don't need to copy and paste. I simply refer to my my variable and then usage key, which is the name of the column containing that information. Then I'm going to say, okay, please spread again to specify another column. So in this case, I want 100, and I want my country to be Australia, so AU. Then I want another thing else in here. So I want my occurrence status to be present only data, which is present. And then I want to only keep records that have been georeferenced, that is, it has latitude and longitude associated with each observation. So I'm just going to use path coordinates and then for. And then I'm just going to run this. So again, this is, you can just go play open. And this will take a little while. And then we have, that's the query that we have. So this is only downloading kind of like the metadata of the data set that I'm interested in, but I don't have access to it yet. So I need an extra step to actually download that data. And I use CC download get. But if I want to check the status of my query, I can use this option, CC _download _wait. So this gives me an idea if my query has been processed, if it has succeeded, if there are any errors. So if I do OCC download and the name of my query, which I save as a utility query, it's telling me that it has succeeded. It gives me a DOI in case, if I do any sort of research, I can just provide that about my citation and give me the other details in there. That the next step will be. So once I make sure that it was successfully found, I can go and download it. So I can use OCC_download_get. So in here it will need a key, which will be my SLE query. Then the path is simply, if I want to download this somewhere in my files, I just provide a particular path. So in this case, if I look at my files here, RStudio can give you information about all the files associated with your project. So I have a data folder, which is what I provide here, the data and then slash to indicate that it's a folder. Then I just want to override it. I just put yes, because used this a few times. If I don't put it in there, or if I put false, it will give an error. And then, yes.
Sorry, we get an unauthorized message when we try to download the data. I'm guessing we didn't set up the account right.
Yeah, so you just need to, if you get that, you need to go back to the first step.
Yeah.
Which is about, so for the people online, the question was that they get an unauthorized error with the data, and that is because this has not been done. So you need to edit the R environment. So I didn't actually do it because it will show you my login details, and I don't want that.
Yeah.
But you just need to run this. So again, you can go play here or Control Enter. You will open up a new little tab in here with the name R environment, and you will need to, in that new tab, use this information in here. So you need to specify your GBIF user, so it's the username, GBIF password, which is the password you use for your account, and GBIF email, which is again the email that you use for GBIF account. Once you have that, you save it. You can close that then, and you just need to restart your R session. So you have the option of doing Control Shift F7 as it says here, or you can go to session and then restart R.
Yeah, we
did
that.
And it doesn't.
No, but maybe.
Yeah, just make sure that your account is active. Maybe check your, if you just created that, check your email address.
Okay.
Are people online having the same issues? You can activate your microphone or.
It took a while for me to send the confirmation email from GBIF, but
Yeah, that's okay.
yeah. But it worked, after that it worked for me. So.
Okay, so you may not have received a confirmation email yet. So if you haven't, you also get, okay. So, and it's also getting an issue. So just make sure that you have set up your R environment properly with what you're seeing on the screen now, the user, the password, the email, and that you have checked your email account to make sure that you have activated your GBIF account, otherwise it won't work. So check your email, make sure that this is all correct, and once you're done, you should not have any issues anymore. Okay, so I'm just going back to where we were in here. So, as I mentioned before, I already explained what this is doing. So this is actually downloading the data. I'm going to download it to my folder called data. Then I'm going to do this import thing. So it loads it to my environment. So to R itself, otherwise it will just download it to my computer, but it won't load it to my environment here. So that's why I'm linking it to OCC download import. So it will download the data and put it in R. So again in here, I just put the information, the name of the file that I want this import to be shown as. the data, the path, which is the data folder, and I want any NA string, which may show up empty, to actually be labeled as NA, and that will help me when processing the data afterwards. If you want a different value for NA, you're welcome to do so, but it is much easier if you just use NA for values that are empty. So in here, if I just load this, we can see that it's downloading the file. If you're still thinking about it, it has downloaded. This is not an error. It's just telling me what it has done, what it has saved, this information. It has just telling me that there are some issues with the numbering thing. That's one that is so good. And then I can start manipulating data. So as I mentioned before, the data is now loaded. So we need off for Australia because it's only the observations from Australia that I was interested in. So it gave me 1,170 observations, and it has 257 columns. So if I see these, again, I'm going to use my glint option in here, and it gives me an idea of all the columns that are available and the examples of the values in the first few rows. I can also do something like S, for example. If I just want to see the first few rows, so I just specify that I'm using S Levini Australia, and I can even give it a number. So I just want the first 5, for example, and it gives me the information. But it's not great because, again, as I showed before, it gives me just a bunch of text that is not particularly, useful to see. It's hard to kind of distinguish which one is which. That's why I prefer glitch. Or you can also do str, which is from base R, so it comes with the R, the language itself. You don't have to load any other packages unlike links, which is part of the packagers. So if I go to structure, SVD underscore Australia, it will give me similar information. So which one you use, it depends, it's up to you. It's not like one is better than the other, it's pretty much the same information. Okay, so this is useful if I want to know the names of the columns, and if I want to search for particular or filter my database. It is useful to have these printed so I can actually find the things that I need, as we will see in a little bit. So, there's like 257 of them, so it will probably go for quite a while. And after that, I can actually save this to my disk. So I can do that by using the write.cfd. So I want to store these data set as a CSV file, so that's a comma separated value. It's really simple. You can use it with a bunch of different programs. I like using that particular file type. So I'm just going to provide the name of the file that I want to store, which in this case is the Slovenian for Australia. And then in the file, I'm going to give it a file path. So here, I would say I want you to store it in data as sloveniaustralia.csv, and then I put this row.name equals false because I don't want it to store the first column, which usually passes the number for that particular row. So I don't want that. I don't need that. So that's why I put false. If you do need it, you can set this to true like this with a T, or actually write the whole word in capital letters. But I'm just going to write it, and if I go to my little folder in here, data, you see that Slovenia underscore Australia is saved as I are here. Great. So I can start summarizing my data. So for example, I want to see how many individuals I have in my data set based on their sex, male, female, or unidentified, and the life stage, for example. And how did I get this information of sex and life stage? again, it goes to that printing of all the different columns that I have. So if I just run this one here, it will give me this table. As you can see here, it's fairly simple to get a table with a count using the option count, and then just telling it what columns to use to create it. So in here we see that we have females, males, and unidentified, which are shown as NA. There are different life stages like immature, mature, adult, juvenile, unknown, and there's a few where we have no values. But we can see that most of them are identified as male and female. Actually, no, most of them are identified as nothing. We don't have any information about their sex or their life stage. And as you can see, it's 1,015 or 1,170. So maybe it's not a good idea that we do any sort of analysis of this data based on either the life stage or the sex of the animal. We can also have a look at, how many observations we have per state, for example. Again, I got that state province from actually checking the printing of all the columns. So in here we have like, okay, New South Wales, Northern Territory, but again, most of them, they do not have any state associated with it. So if we want to check observations based on the state, we need to do further processing before we can do this sort of summary table. This is not covering this particular workshop, it's just showing you how you can make a simple summary table. Okay, so if we, and again, if you want to see for example, the unique values of any column, we can use the function unique, followed by the name of the variable that where we store our data, which again is the Slovenian for Australia. And then I want to see, for example, organism quantity type. So it says that this refers to how the data was stored under the quantity column. So it's telling me that some of them are NA, so there's no information about what they need by quantity type, but then the rest are for individuals. So the number they have recorded as quantity refers to the number of individual things. And here I also include a link to where you can find more information about the different columns that you have available when you download data from GBIF. There's quite a lot of them, so I really do recommend that you have a look at the list, and also it will give you information about how they do their quality check, for example. And now we're going to create a simple plot with ggplot. We are going to use our data set, which is Slovenian Australian. I'm going to create or change a column. So in this case, I will use mutate, which again create or changes an existing column. So individual count already exists. So what I'm going to do is I'm just going to replace NA. So any rows that have NA values in it, I'm just going to go individual count equals 0. And why do I choose to do this and not set them as there isn't actually a value in there? Because if we go at the very top when we do the query, I ask GBIF to only give me data where there was occurrence. There was actually how do you say this? I only want data where they recorded the occurrence of these animals. So if they recorded an observation, it means that they were looking for this animal, but they did not find anything. So if I didn't set that option, so if I go back up, So in here, so when we did the search query, I said occurrence status only when present. So if I wouldn't have said that as present only, then I would not recommend that you change any values to 0. Only because I did that, I can be fairly sure that they recorded the occurrence. They didn't record any values of the occurrence because it was 0. It was simply not there when they did the count. Okay, so this is, yeah. So we go back to where we were. Again, organisms, yeah.
Sorry. So when you do when you ask for presence, it doesn't do automatically 0, 1, but it gives you any instead.
No, it shows up as nothing in there. So if I go back up again. So in here,
Yeah.
yes, so I said that it has to be present only.
Yeah.
And then when I downloaded the data, I said that anywhere where there's nothing in that cell,
Okay.
I set it as NA.
Okay.
Yes. That's why I showed it as NA. If I wouldn't have done this, then it would have come up as empty.
Empty 0, yeah.
Yeah. Okay, so organism quantity, I do the same thing because I know that they were looking for individuals, but they were not found there. And then I want to create a new column that has these two, that merges this information into like one column. So individual count and organism count, because in both cases they refer to individuals, and sometimes they just put two different values in there. So I'm going to assume that they are meant to be added. Whether you should be doing this or not, you have to check the quality control information that you have here, and then you can decide what's the best way to deal with this data. But in this case, I'm going to simply assume that they refer to just the animals that they found there. And again, I base that on the fact that they were including only individuals as the organism quantity type. Okay, so once I do that, I create those new, I change existing information in the existing column. I'm going to do create a new column that is called count, which is going to do a sum of rows. So row sum will look at each row individually, and then it's going to add up anything that is across individual column, individual count, and organism quantity. So I put this column in the middle, this is in here, because I wanted to go from individual count to organism quantity. So it just gives you a range, essentially. And across, it just includes everything that is in between there. In this case, it's actually just the two of them that are in there. So if I go, but if you go to the printout of what we did before about the structure of our data set, you will find that they are binary trees. And then what I did here is create, once I create a new page, I'm going to say, okay, when count is 0, I just decided, this is just to show you like what else you can do. This is not necessarily what you should be doing. So I'm just saying like, oh, when it's 0, I actually wanted to show 1. If not, I just wanted to show the count. So this is, again, this is just showing you how to use different functions in R. So in this case, it's just case when, which is giving it a condition. So in this case, if count is 0, I'm going to change it to 1. If that's that condition is not met, then I just keep the count. Then I'm going to drop any NA any rows that have an NA included under the year, because I'm only interested in having data that has the year recorded in there. I'm going to group these by year. I'm just going to summarize it using the sum of all the animals that were found in a particular year. And now I can just simply plot it. So as you can see, everything is linked by this pipe. So I don't have to save the data anywhere. I can just keep linking things together. So I just go, once I summarize this, so if you want to have a look of what this looks like, I can just highlight what I need. So here, for example, I go summarize not end count. So you will see that in here it will print. It will print the years and the sums. So it's telling me here it has 54 rows. So it starts in 1878 with just one animal. In here showing you 1966 with 13 animals. So if we go to like 2021, it comes 4 animals. So that's kind of like what it's using to create the plot that you want to show. So you're going to see first. Then I'm going to use ggplot. I'm going to have the y-axis n, which is the number of animals that we see here. In x will be the year, which you see there. I'm just going to use points, lines. Let me show you what it looks like. So that's kind of what it looks like. The points and lines for each year. I can change what it looks like using this theme black and white. BW already has been kind of like has pre-established parameters, so you will see that this background is no longer gray. But you know, if you want to use anything else, you can. I'm going to change the labels by using that, Y and X, and then I'm going to give it a title. So if you see here, there's no title including here. My Y axis here only says N, which is not particularly useful if to someone else looking at this graph. Probably the only thing that is useful is this one here showing the year. And here I use this option expression, which lets me itemize the name of the species. So I use this expression, and then I'm going to paste all these together. So it's having the bits that are not itemized and the bits that I want to itemize. So here I put italic, just the name of the species, and then everything else is just pasted together. So if you want to see what this looks like, it's going to be that. Preset. Anyway, but it's missing once it's in there. And I'm also going to include a caption. So it's like a footnote sort of thing at the bottom of the graph. And then the final thing that I want to do is just make sure that my title is in the middle, is in the center of the horizontal. If I want all this, we will see that the plot looks much nicer. So you see that now Serena is itemized in there. My title is in the center of the graph. I can see that again that background is no longer gray. I have changed my labels. You can see, and then that's my little caption in there. So it says an includes observation for which there is no year report. So you can make plots fairly easily. You don't need to spend too much time doing this, and you can actually kind of look at the data and manipulate the data all in one go. You don't have to store in between variables, I guess. So that's kind of like how to access the GBIF data and how to have a quick look at how to summarize data using counts, for example, how you can do a little bit of processing using mutate, and how you can do a quick plot using plot. And this plot can look a lot better, of course, if you want to. So do we have any questions at the moment? No? Do you want to have a quick break, or should I just go with the mapping? I think I'll go with the mapping. So the mapping is in that mapping underscore GBIF data. So it's going to use the same information that we downloaded before, so there's no need to download anything else. So again, because this is a new notebook, we use that this meter option that is just telling it I want to show each chunk of code. So I'm just going to show you what I mean by that. So if I click on my HTML file, I'm just going to open it in a web browser. So this is what it does. So it shows all the gray bits in your HTML. You can do it as a doc, Word document or whatever you want. Again, there's more information here about what we're doing. So the reason why we only chose geo-reference data is because we actually want to map this stuff. That's why we included everything else. We're going to use a couple of libraries. So the libraries that we had before, and Leaflet, which is pretty good for creating maps that you can interact with. So because we already saved our data, if you remember, we have in our data folder, we saved a CSV file. So let's say that we, pre-process the data the way we wanted it. We can come back to it just by simply loading them instead of having to do the query again directly from GD. So we save some time. So I'm just going to load it. So it's the same data that I had before. Here it's telling you what my data set looks like, the types of columns that I have, and it's telling me here that these last few columns I need to check them because they might have not been loaded correctly. So now we start cleaning data again. So as we did before, we're going to do a bit of like the counts. We're going to clean them up a little bit. So this is essentially the same thing as we did before. But instead of doing just a summary of the number of animals per year, I'm going to select a few columns instead of the whole data set that has 257 variables in there. So if I just run that section, so by using the select and actually putting the names of the variables that I want, it will show you only those columns. So if you see here, there's only 3 columns. So that way I don't have to go through the entire data set to only see what I want to see. So I just want to have the count. I want to have the latitude and longitude, so I can plot them. Then I want to rename my latitude and longitude column, mostly because Leaflet I then can only recognize the coordinates if they are named latitude and longitude. So that's why I'm using the rename function in there. And then I'm just going to group by latitude and longitude, and I'm just going to summarize them. So I just want just one value for a particular latitude and longitude. So if they have multiple charts in that particular site, I want that to be recorded like that. So if I run all these, this is what I get. So now it's called latitude, longitude, and my counts now include the sum of all the animals that were seen at that particular place. Okay, so we're going to take these. So now we see that I have this SLD map, which is the data that I'm going to use for my map. And I can check if there are any issues with my data. So there is this column called issues in the dataset that we download, and that gives you information about any possible problems that that particular observation has. So it could be anything from, there was the coordinates that they give do not match the place, for example, where these observations are supposed to come from. That is all specified there. So what I'm going to do is I'm going to just select that issue column from my original dataset, and I'm going to find just the unique entry to see what were the issues or mistakes that were included in this dataset. So in here I have mostly related to my coordinates, so it says that it has been rounded, so it's not very precise. So here the precision is invalid. The date that it was recorded was invalid. It's telling me all this different information, but there are some that are very clear, like this coordinate is rounded, we can understand what it means. But there will be other ones like this, here basic data assume WSD84, like people may not understand what that means exactly. So you can check what this particular issue means by using the GBIF issues lookup. So in here, if you noted before, I didn't load the RGB library. So if I go back up, I only loaded two libraries, the tidyverse and leaflet. So that's why when I'm using that GBIF issues lookup, I actually need to call RGB first. So specify this is the packet where it comes from, and then I give it that particular function the GBIF underscore issues lookup. So I can give them an issue. So in this case, I just copy that data to WSD84, that's to see what it means. And then I'm just going to print the content of the description column, which actually tells me the description of this particular error. So here it says that it means that my coordinates are supposed to be in that reference system for using the station WGS84, so there are latitude coordinate and longitude, so degrees of latitude and longitude using that station WGS84. And I can fetch for all the issues that I'm not sure what they mean. For example, institution match copy. I can include that information here. And we'll change it there, and it will tell me. So that partially match is like a partial match. That's what they need. But again, you can find information about this in the links that I provided in the first notebook to guide you to where you need to go. Okay, so now we can have a look. Now that we have seen that we have, at least 19 different, you can see 19 rows, 19 different types of errors. We can have a look at how many of our observations actually contain errors. So we can just go to our initial data set. We can go and drop NA issue. So where there are no issues, I just want to drop it, and then I want to count how many do have issues. And it will print the number of observations that have issues, that is 1,151, which is, that means that only 9 of them do not have any issues associated with it. So what do you do with that information? It depends on what you're doing and the type of error, I suppose. If there's an error in there that says, this is, we know that this is wrong, maybe you want to exclude those observations from your analysis, but we're just going to keep going follow with this just for this example. But this is mostly to show you that we shouldn't just accept that all the data is correct and we can just use it. You just need to be careful and actually have a look at, are there any issues, are there any implications in there, and how you fix it depends on what your question is and how much imprecision you can tolerate. Okay, so now, like I said, we're going to assume that it's all fine. So I'm just going to use that summary that I did with the SLOWINI map that only contains 3 variables, so it's simple for me to use. So I'm going to use that information in there. I'm going to just create a sample. So basically, I just want to see what that looks like. I don't want to use the entire data set. So I'm just going to use 10% of that is going to be selected randomly to create a map. You don't have to do this. I just wanted to do it just so it doesn't take too long, because you can see there's over 1,000 observations in there, so it might take a long time. And then I'm going to start a map using Leaflet, which is, as I mentioned before, the package that allows you to create these interactive maps. Then add files is basically adding a base map. Otherwise, you will just have your observations in there. You won't have any sort of like nice little map at the bottom. And then we're going to add markers. So using latitude and longitude, we're going to add a little marker, and I will show you what that looks like. And here, I want to add a pop-up. So every time that I put my mouse over a marker, I wanted to show the value of n. So if we remember what we did before, n refers to the number of animals that were found at that particular location. So I'm just going to run these. So again, this is going to show only 10% of the data, so you won't see that many. But you still see quite a few, 700. So there we go. These are the observations. So those are the markers. So if I put my mouse over it, it will load. There we go, number 1. So there's one animal in there. There was some. I actually have to click on it. Number 1 in there. So most of these are actually just one observation that was recorded at a particular location. So there's 4 in there. I can move my map if I want to. I can make it smaller, or I can just do it as well. So that's the good thing about this. So now that I see, okay, that kind of like looks to what I want to do, then I'm just going to add all the observations. So I'm not going to have that sample thing that I did before. If you notice, we just went and did that slice sample and only took 10%. Now that I see that, yes, this is sort of like what I want, then I'm just going to plot everything in there. So that's my map now. But then we see that in my map we have like these 3 observations, like almost next to Madagascar. So that's a mistake in there. So we can start processing the data a bit more to remove any observations that are not actually in my area of interest. So in here, it actually shows you how to do this. So I know the longitude is the smaller longitude means east. So I'm going to here filter out anything that is the smallest or the minimum of that value in that decimal longitude, just to see which one it is. So I'm just going to check. So it's telling me there's actually 4 different observations that have been recorded in that particular coordinate, and I can see the issue in here, and it's telling me that there's a mismatch with the coordinate and the country that it was associated with. So maybe that's something that we should have like read more carefully before like loading the data. So yes, that we can then remove them from our data set. We can also look at exactly what it means, the country coordinate issue, for example. by using the GBIF issues. So again, it's telling me that the coordinates need to apply the indicated country. So when we did our query, we put in there that we want only information for Australia. This was actually labeled as Australia, but it's not. So now that we have confirmed that this is, something that is meant to be an error, we can then remove that particular or those observations for observations. We can do that by using filter. So we use this exclamation mark in here when we want to exclude things. So exclamation and equal means that's not equal. So the longitude column cannot be the minimum of the minimum value in that column. So that's how we're going to remove it. Fairly easy. The rest is the same. So if we do that to check our data, so now our map looks a little better. There's still some other coordinates in there. There's Indonesia. There's a couple in Papua New Guinea as well. So we can, you just need to make sure that you filter out those using, the techniques that I showed before. But I'm just going to assume that everything's fine now. Keep going with it. And then I'm going to show you as well how to do clusters. So this key here, there's like a bunch of markers in there, so it's hard to see how many exactly were in each area around Australia or each state. So I'm just going to have to look at the sum of all the animals that they have included in my data set. And then immediately I see that there's something that is not quite right because I can't have an animal in there. So I need to identify anything that has a decimal in the individual count because this is definitely not right. So, yes. So I'm just going to filter out anything in here. I don't know what's happening here. I'm sorry about that.
That happened to me as well after the map got launched. It just messed with the window for some reason.
It happened to me when I did this because I thought that so yes, what I'm going to do now is just filter out any rows where you have information, counts that have decimals. How do I do that? If I use the modulo function, which is this one here, the two percentages. So basically it says what's the difference if I divide number by whatever number. So if I say 10 modulo 2, so what's the difference if I divide 10 divided by 2? I should have 5, that's the result, but I don't have anything left over, so this should be 0. So then if I go to 11 divided by 2, I have the answer is 5, and then I still have 1 left over, so the modulo will give me 1. So in here, when I divide by 1, if I go 11 by 1, it should be 0, but if I go 11.5, the difference or the leftover, I don't know how much it is, sorry enough, is 0.5. So that's why I'm using this modulo thing. So anything that is divided by 1 and has some sort of difference that is not leftover, that is not 0, it shouldn't be included in here. So that's what I'm doing here. So I'm looking at individual counts and organism quantity, removing anything that has a decimal value, and then I'm going to select only the columns that I'm interested in. So individual counts, there's no information in there, but we see that the organism quantity, there are 2 rows that have decimal values, which should not be the case. even though it says in there that this refers to individuals found in that particular site. So I don't know how this, if this should be 491 individuals, which is very unlikely, so that's why I'm going to remove them. But again, what you do with this information depends on you really at the end. Okay, so in here, I'm basically just going to make sure that I remove the information, all the observations that have decimals. I'm going to rename the decimal latitude, the decimal longitude to latitude and longitude. So basically, what I did before with Slovene map, but removing any observations that are like in New Madagascar and the ones that have any decimal values. And then we can plot it. So here we just count, for example, the number of animals that we should have. And then we create a new map using the new map equity map. In there, I'm going to, instead of using the markers, I'm going to use circle markers, and it's going to basically take all the observations that are within a 1 degree radius, and it's going to add them all together, and that's going to be the data from the cluster. And if you notice, when I went Control Enter, nothing happened. It's because I actually stored my map in this variable. So if I want to see my map, I have to call it. So map Slovene. So now my map is in there. So then I don't have like a bunch of little markers in there, but like all the markers within a 1 degree radius have been put together. So now I can see that there are 168 animals within that polygon that you can see now. If I click on it, we will like bring it closer so you can see how many observations are within that radius. And if I want to save it, for example, let's say that I want to save it in a folder called map. So this is just an example of how you can check that a folder exists and how you can create one if it doesn't exist. So let's say that I want to just store my little map in a folder called map. I can check if that folder exists by using the function called here from directory and .exist from basically that this directory exists, and then just included the name of my directory, which I want to call map. I put an exclamation mark in there, which means the opposite. So as we did before, the exclamation mark equals means not equal. So in this case, it means that if this directory does not exist. So we put the if before because we're going to evaluate if this is true or not. If it's false, then it's going to create a directory. If it's true, nothing is going to happen. So in here, because I already have a directory called map, nothing is going to happen. You see once I Control Enter. So it's going to look at it, but then it's not. Like it's going to create another map folder because that already exists in there. So if I want to just to show you how it would work, so if I go directory exists, and then the name of the directory. So I can even, one thing that we should also keep in mind is that these names have to be written exactly as how they were created. So if I go to map with all lower small cap, you'll see that this will say, oh, this is really weird because we shouldn't do it anyway. But anyway, but just make sure that you write the name of the directory as you wrote it in your actual folder. And now I can save it using these HTML widgets, save widget, because this is computer. We can save it as an interactive map. And I just use the name of the map, which is what I saved as before, and the file path, which is map, and the name of the file. So if I do that, we save it, and if I go into my map folder, we can see that it has saved that as an HTML file. So if I click on it, I'm opening the web browser, for example, then I can see the map, and I can use it still interactive, so I can still do everything that I did before. So you can share these or put it in your website or whatever. So that's basically it. It's not as complicated as it might seem. To create an interactive map, you can make nicer plots if you want. You don't have to make interactive maps. If you don't want to, you can use sticky plots to just plot all the occurrences and whatever you want. But I think that the key of this workshop was to show you how you can access the data, how you can pre-process it, and how it's important that you check the quality of the data. Don't take a data set that's it is perfect, because as you saw, there are some issues. So you need to be very thorough in checking your data before analyzing it or plotting it or doing anything to do with it.